Hi and welcome to video 9 on this series from Unit 4, Topic 3, Networks and Graphs of the General Maths curriculum. And in this particular video I'm going to talk to you about network cuts and how we can use cuts on a flow network to determine the maximum flow. This is called the minimum cut maximum flow. If you can work out the minimum cut, then you've automatically worked out the minimum flow. Let's talk about why. So we take a flow network and apply cuts to it to determine a cut capacity and eventually use these techniques to determine the maximum flow. And so there's important language in there, cut capacity, and obviously we've already talked about the maximum flow. And there's our flow network, you've seen that before. And here's a cut. So remember, our source and sink in this flow network were A and D. And this pink line is a cut. A cut is where you cut or you block a network, is another way of thinking about it, from the whole way through the network, but that separates the source and the sink. So this is kind of like a blockage. What would happen if I blocked there? What capacity am I stopping in this cut is an important feature we'll be talking about as well. So here's that cut as the imaginary line, and I've introduced one, but there's many different cuts that can be introduced. The cut capacity is the sum of all the capacities on the cut that are flowing from the source to the sink. So the cut capacity here is 10 plus 7 plus 8, because this goes through each of those edges, the 10, the 7 and the 8 flow edges. So there's a definition of cut capacity, and there is a flow network. Here's an example. The source and sink, same diagram. The cut capacity of this diagram is, and it creates an important situation. The cut capacity is this 8, which is my B to E, and then it's this 7, which is my C to D. No, not 7. That is wrong. My apologies. 9, which is my C to D because it goes through that line. And then I've also got this 10, which is my A to F. But I've also got this C to E. And so we need to talk about that very quickly because this is important that you understand. A cut should block everything from the source to the sink. But I've introduced this new edge C to E, and you can see that's flowing from E to C. So this is actually cutting a line that's flowing from the sink to the source. So what do we do with this? Well, if we're talking about a cut capacity in the respect that we want to be able to look at maximum flow, this is not blocking anything from getting to this from the source to the sink. It's blocking stuff from getting back. And so in this case, it actually counts for nothing. And anything that is a flow from the sink to the source contributes nothing to the cut capacity. And if you go back and read, the cut capacity is the sum of all capacities on the cut that are flowing from source to sink, not from sink to source. And so this contributes nothing, which means we have a cut capacity of 27 on this cut. Goes through that dotted line there. So that's that example. Let's look at another example. Oof, out of this world. There's 7 cuts on this diagram. We're going to determine the cut capacity of all 7 first of all. So I'll do them over here. C1, C2. So C1 has a cut capacity of 11 and 10. So 11 plus 10, which is 21. C2 has a cut capacity, we've done C2, 8, 7 and 10. 8 plus 7 plus 10, which is 25. C3 has a cut capacity of 6 plus 7 plus 10. 6 plus 7 plus 10, which is 23. C4 has a cut capacity of 8 plus 9 plus 10. 8 plus 9 plus 10, which is 27. C5 has a cut capacity of 6 plus 9 plus 10. 6 plus 9 plus 10, which is 25. C6 has a cut capacity of 11 plus 5. 11 plus 5, which is 16, and C7 has a cut capacity of 8 plus 9 plus 5. 8 plus 9 plus 5, which is 22. So hopefully you're able to negotiate this diagram and everything I'm saying there, and you can obviously pause the video and have a look at where I've got those numbers from as you need. Now, we're halfway through the video, so it could be a good time to check in and make sure that you're all still awake with this quick joke. Did you hear about the kidnapping at school? It's okay because he woke up. And hopefully you've woken up as well. So let's carry on with the question. Determine the minimum cut capacity. Well, that's a pretty easy question. I'll go through this list, and 16 is the minimum cut capacity. In this case, I've got 7 cuts. There's actually more, so I have to be a little bit careful. But based on my analysis, that's the minimum one that I have. Determine the maximum flow. Well, if you recall from the last video, the maximum flow of this network was this 11, because remember we did talk about the 6 and the 7, but they couldn't be fed enough flow. And for flow network number 3, the single line network that went from A to F to D, that was 5, and so it gave us a maximum flow of 16, which is really interesting because that matches our minimum cut capacity, and it tells us that the minimum cut capacity equals the maximum flow. Now, contextually, we generally don't care about the minimum cut capacity, but we do care about the maximum flow. The minimum cut capacity, introduced by cuts, is easy to find. We can just throw a load of cuts on and do an analysis. The maximum flow for a larger network can be quite hard to find. So this is now a tool to help us determine the maximum flow. Are there any cuts missing? How can we optimize this process? So are there any cuts missing? Yeah, there are. So for example, a cut, well, I think there are. I'm pretty sure there are. You could have a look at this and analyze. I see here that 11 has to go through both AF and FD. So 11 covers flow 1 and 2, and AFD covers flow 3. So there's 2 options there. You go through 8-7, and then there's 2 options associated with that 8-7, which we haven't actually got the second option. So going through 8-7 and 5, so that one's missing. We go through 6-7, and then there's 2 options, and we're missing a 6-7 option, aren't we? So this 6-7 and 5 is not selected. We go 8-9 and 2 options, and we're missing one of those. 8-9 and through the 5 we've already got here, that's C7, but 8-9 through the 10 was missing. And we go through 6-9, and we're missing a 6-9 too, so this one here would be another option. So it turned out we were actually missing a few, and there may yet be more. That's the only problem with this minimum cut capacity type approach. There's a lot of cuts that you could introduce even in a simple diagram like this. So an approach could be to make sure that you've got them all, to actually just go to take out the obvious ones. So in this case, AFD 5 is our maximum flow. So let's just not worry about doing any of them through 10, because 5 is going to be one of our answers. And so using a bit of logic, you can actually determine the maximum flow by introducing appropriate minimum or appropriate cuts and not worrying about the cuts that don't actually help. So there's still a bit of logic involved, and hopefully you can work through the how do we optimize by doing some practice. So the minimum cut capacity is the maximum flow rate, and my question to you is, can you sketch and use a flow diagram? Can you determine the maximum flow observationally? And can you determine the maximum flow with a minimum cut method? And of course, I haven't copied the questions, but whereas at the end of last lesson you could do question 3, you can now complete 11C, and you can work on a chapter review. And I'll finish this video off with one last example from a D2 exam paper, June 2016. And here is a much more complicated flow network, and we probably wouldn't expect you to analyze something like this in an exam because there's just too much going on. A few things to note first of all. If S is the source and T is the sink, you can see this because everything flows into T and everything flows out of S, and all the other ones have a different situation. because of where the cuts are, it had to be S or B that was the source, and it had to be T, D, or F that was the sink. So just be aware of that. These arrows are flowing up, this arrow is flowing down. So keep that in mind as well. There's some just slight things you have to notice in this diagram and apply appropriately. Make sure that our minimum cuts are calculated appropriately as well. So find the cut capacity of each of the two cuts. So first of all, C1, all of the arrows are flowing from source to sink. I've got 4, 12, 13, 15, and 5. And so my cut capacity here is 12 plus 13 plus 15 plus 5, which is 35. And C2, I've got 10, 5, 13, 15, 4, 11 is going the wrong way, 5 and 21. And so my cut capacity here is 10 plus 5 plus 13 plus 15 plus 4 plus 0, that 11 doesn't count, plus 5 plus 21. And so that is 28, 38, 43, 47, 50, 67, 73. That's my C1 and C2. And given that one of these two cuts is the minimum cut, write down the maximum possible flow through this network. So we're given that one of them is a minimum cut, and therefore the max flow is equal to the minimum cut, and that must be 35. And you can see that there's restrictions here. Once we get further along the diagram, these 18, 28, 21, they create plenty of space for flow, but we are restricted right at the start with how much of the water or the cars or the people in the crowd can flow into the network initially. So there you have it. That is flow diagrams and cuts. Hopefully you understood that, and obviously it's important that you ask your teacher any questions that you have. All the best.